As was said, I work for EPFL's EssentialTech Center, and our mandate is technology innovation for development and humanitarian action. Now, there has been a foundational question that has been guiding our work ever since we started our activities a little bit less than 10 years ago. And this question is, how can we harness technology innovation in order to generate a sustainable, large-scale impact? I will present you what we have learned about this question, but first, let me set the stage and say a few words separately about development and humanitarian action, which are in a way two sides of the same coin. Let me start with development. This is the city of Lagos, Nigeria, and you can see the modern city in the background and the urban slum in the forefront, where people live in extreme poverty. Actually, 1 in every 5 Nigerians lives in a slum such as this one. To me, that's a very good illustration of the rise of inequalities today, where you have parts of the population who are wealthy, who benefit from the advancements of science and technology, and other parts who are desperately poor and left behind. So let me say a few words about the state of poverty today, and show you this very simplified view, of course, which is roughly how the World Bank classifies countries into 4 categories. First, we have low-income countries where people live on roughly about less than $2 per day and per person. This is considered extreme poverty. Then we have lower middle-income countries where people live with between $2 and $8 a day, and then upper middle income between 8 and 32, and above 32, it's the high-income countries, and you know we are part of those. Although if you calculate, someone in Switzerland living with $32 a day would be considered quite in a bad situation. If you look at this picture, every one of these characters represents roughly 1 billion people, so you immediately see that over half of the world's population today actually lives in the 2 first categories, which is low-income and lower middle-income countries. That is precisely where we have decided to focus our attention. Now, there is a global initiative to fight poverty, which is called the Sustainable Development Goals. I'm sure you all have heard about those. These goals have been aimed to promote sustainable development and fight poverty in all forms. They were approved by all the member states of the United Nations in 2015, who commit to achieving these goals by 2030. Note Goal 17, which stresses the importance of science and technology for development. But let me focus on goal number 1, and in particular on the first target of that goal number 1, which aims to eradicate extreme poverty everywhere. And let's look at how the countries have been doing recently and how they will be doing in the next decade if everything remains unchanged. This is what this map represents. You can see the countries in white have no extreme poverty, as defined by the World Bank, or the level of extreme poverty represents less than 3% of their population. You immediately see India. It's an interesting case. India has about 40 million people living in extreme poverty today, which is less than 3% of their population. Of course, living on less than $2 a day is a very rough vision of the state of poverty. It's very approximate, as we still know that in India there's many, many people who live in poverty. But it shows you the tremendous progress that this country has made. The countries in green are those where poverty is coming down, and coming down fast enough so that if everything remains unchanged, these countries will reach their eradication target by 2030. Then we have the countries in yellow, where poverty is coming down, but not fast enough. So these countries are off track. And finally, the countries in red is where poverty is not going down, but going up. And again, let's look at Nigeria. We have in Nigeria about 200 million people living there. And out of those 200 million, 94 million live in extreme poverty, which is over twice the amount of the people living in extreme poverty for the whole of India. So for us, when we see this, it's very clear. for now and the decade to come, we need to focus on Africa. That is very clear. Let me say a few words about the other side of the coin, which is humanitarian action. And when we talk about humanitarian action, we have to talk about humanitarian crises, which trigger this humanitarian action. And there as well, there have been changes in the latest decade or so. Humanitarian crises are protracted. They last longer. In average, in 2005, a humanitarian crisis would last for 4 years. A decade later, the average duration is 7 years. They're also more frequent. In 2005, there were 16 ongoing humanitarian crises, and it has increased gradually, and a decade later, it has doubled, over 30. They're also taking place more and more in urban environments and are generally caused by conflict, and in particular, internal conflicts. They're also the case of climate change, which is a catalyst, as we know, which makes everything worse, and we will see more climate-induced crises in the decades to come. And finally, poverty, vulnerability, and crisis are inherently linked. Over 50% of the people who live in extreme poverty also live in areas which are susceptible to environmental and man-made disasters, which is very clear from this map, which shows you where humanitarian crises were in progress in 2018. And again, very clearly, Africa is where we need to focus our attention. Now, this being said, let's come back to the role of technology. We know that technology can be an enabler for development and that it can support humanitarian action. But what we also know is that technology is not a silver bullet against poverty or vulnerability. That said, let's ask the next question: which technologies are important? We've looked into this question in quite some details, and we found 8 technology domains which seem to play a fundamental role in the fight against poverty. We call these technologies essential technologies. And they're the ones related to pharmaceuticals, to medical equipment, to energy, to information and communication, to transportation, construction, water and sanitation, and food and agriculture. Interestingly, about at the same time, the International Committee of the Red Cross, which is a large humanitarian organization, had conducted a similar analysis, and they came out with the same list of technologies which they find important for humanitarian action. Now, the good news is that technologies exist in these domains. We use them every day. The bad news is they have been designed for the context of industrialized countries. I remember very clearly when I was in industry, the mindset was something like, let's design it for the West, and it'll be fine for the rest. Unfortunately, that doesn't work. Why? Because the context of low-income countries is very, very different from the context of industrialized countries. And there are 4 main differences which characterizes this context in the perspective of technology, which we call the 4 horsemen of apocalypse. The first one is quite obviously a lack of financial resources, which affects not only the capacity to purchase the technology in the first place, but also to pay for consumables, for spare parts, for transportation, and other things like that. The second one is a lack of trained personnel who is able to use properly this equipment, which can sometimes be very complex, but also to maintain it and to repair it. The third one is a lack of quality infrastructure. For those of you who have been to those countries, we know that power is unstable, there is power outages all the time, roads are in bad shape, there's no access to clean water, sanitation, etc. And the fourth one is a harsh climate. It's hot, humid, and dusty. Due to these key differences, technologies designed for industrialized contexts cannot simply be shifted to the context of low-income countries. Because if they are, what happens is this. This is a picture taken from the backyard of a hospital in Sierra Leone in Africa. And what you see is medical devices which have been abandoned. These devices were, for the most part, donated by individuals or organizations with good intentions, based in industrialized countries. Unfortunately, according to the World Health Organization, over 70% of those donations are never commissioned. Never commissioned. So we can stand here and lament about the horrible waste of resources, which it is, or we can look again at things in a slightly different way. When I was in industry, again, I remember our leadership would constantly push us to go out and look for what they called unmet needs, because that to them meant opportunity. Now, when I see this picture, I see a perfect expression of a huge unmet need, and it becomes an opportunity if we accept that we have to rethink, redesign our innovations for that particular context. And so we also thought about how to do that. And we have come up with a process that is aimed, ideally, to generate that large-scale impact, that sustainable large-scale impact. And what we know is that we have to start by understanding the context and the need. And there is no better way of understanding that context than to collaborate with the people who live there and who are confronted to these problems every day, and co-design solutions with them. In academia, we're very lucky because we can just reach out to our partners, to our peers, based in universities in these countries. And this is why the first pillar of our process is cooperation. The next step is then to demonstrate the technological feasibility of our innovation, but that's not enough. We also have to think about viable, sustainable economic models, business models. And the complexity of such a project requires that we bring in multiple disciplines. It's not just engineering. And this is why our second pillar is interdisciplinarity. We then transfer the technology either to a startup, which we create for the occasion, or to a partner in the private sector who will then industrialize and scale up the technology, hopefully. And this is why the third pillar is entrepreneurship. Now, for this process, the key to the success of this process is to de-risk the technology before it is transferred to the private sector. And we all know what the best antidote is against risk. It's knowledge. So we generate this knowledge via cooperation and interdisciplinarity. Now, let me give you two examples of projects which we have conducted with this kind of approach. The first one is from the domain of medical imaging. This is Wilhelm Konrad Röntgen, who, by the way, got his diploma at ETH in Zurich. And he was the first to make an X-ray image of a human being, and it was his wife. You can see her hand here wearing a nice ring in December of 1895. We are 120 years later, and we still have 2/3 of humanity without proper access to radiology. Now think about that. An invention comes out, 120 years later, we still have 2/3 of humanity without access. That's crazy, isn't it? Now, why is it so crazy? Well, I'm pretty sure most of you in this room have had an X-ray taken at some point. Maybe you fell while skiing, or you fell off your bike. The first application for X-ray is trauma, and there are about 50 million victims of road traffic accidents every year. 90% of those victims live in low and middle-income countries, precisely where X-ray imaging is not available. The second application is tuberculosis, which remains a terrible killer in those contexts, and also pneumonia, which is the #1 cause of child mortality today. So why is this so important technology not available locally? Well, let's go back to our 4 horsemen and look at them one after the other. The first one was the lack of financial resources. Now, of course, an X-ray machine is something expensive. It will cost you anywhere around 200,000 Swiss francs. But that's not all of the math. We also have to factor in consumable costs, which in this case is films and chemicals. It's still done this way a lot, in most of Africa. And also maintenance costs, which can amount to 10% of the initial purchase price every year. Now, if you add up all of this, you end up with a total cost of ownership over 10 years of 500,000 Swiss francs, which is completely unaffordable locally. The second horseman is a lack of trained personnel. We need locally people who are able to interpret the images properly. And these are the radiologists and people who can make the images, position the patient, and make the image properly. These are the radiographers. And finally, we need technicians who are able to maintain the equipment in proper function. All of them are in scarce supply in these contexts. I'll give you one example. In the case of Cameroon, which has a population of 20 million, less than 10 radiologists are trained every year. Now, you can imagine what a young radiologist will do if he or she is deployed to a hospital where there is no access to radiology or radiology is not functioning. He or she will probably leave the country and find a job elsewhere, and that is what's happening. The third one is the lack of quality infrastructure. This is a hospital about an hour from downtown Yaoundé in Cameroon, where there has been 7 fires of electrical origin in just 1 year. Electrical instabilities cause about 1/3 of all equipment breakdowns, according to one study. And the problem is also with capacity. This hospital has a capacity of 30 kilowatts. Well, an X-ray machine consumes 30 kilowatts. So you have to turn off all the lights and everything else in order to take just one image. That's another illustration. You can probably guess what that is. That is patient records in one of the main hospitals in Africa. Here as well, infrastructure would be needed, IT capacities would be needed, but they're not available or failing. The last horseman was the lack of a harsh environment. It's hot, humid, and dusty, and this has taken has had a severe effect on this user interface of an X-ray machine. The only thing that still works is a little green light that you see on the right-hand side. Now, how do we approach this? As an engineer, and I'm sure there are few engineers in the room, I have a temptation, which is to deep dive and focus only on the technology. And yet we know it's more complex than that. In fact, we have to, for our technology to deliver its value to the patient, a whole chain of activities needs to happen, which we call the value chain. So we need to understand how the technology will be manufactured, transported, how it will be sold, to whom, for how much, how it will be assembled, controlled, commissioned, who will provide training, what kind of content, how will it be used, under whose supervision, who will provide preventive maintenance and repairs if there is a problem, and finally, what will happen in terms of recycling. So all of these segments have an influence on the design and have to be taken into account as we develop the technology and not later. The 3 pillars of our approach are quite evident here. Because in fact, when you see most of these segments, these elements happen in the context of low-income countries. So we have to collaborate locally with the people because they know how to use these things and design solutions together with them. Every one of these segments also involves several disciplines. There's no way we can solve them with just with engineers. And finally, entrepreneurship is what holds everything together and assures that every one of these segments is economically viable. If just one element fails, the whole chain falls apart. So I want to insist, inventing is not enough. It's the cool thing that all the media like to report on, but it's not enough. It's just one segment of this chain, and innovation can and should be in all of these segments. So with this approach, we have assembled an international alliance of partners with over 20 partners in Switzerland and in Africa, in particularly in Cameroon, which was our pilot country, partner country. And over 130 people were involved from different backgrounds. They were designers, anthropologists, medical doctors, physicists, engineers, you name it, 130 people. And what the result is a complete X-ray solution, which we think is really adapted to the context of low-income countries, which is co-designed with our partners in Africa. This is just a prototype. This is just a prototype. It costs 4 to 6 times less than existing solutions in terms of total cost of ownership. It is digital. It requires no consumables. It's been redesigned for simplicity so that even people with basic training can use it. Its core components have been redesigned to resist heat, humidity, and dust. And it consumes very low amounts of power, less than 300 watt, which means you can use it with a simple solar set to operate with. It also resists instabilities. Now, all of these technical things have forced us to innovate, and we've filed 3 patents on this particular project. But as I said, that's only technology. That's just one element, and that's not enough. So we completely redesigned the business model and the value chain. And I cannot detail that too much to you, because we've created a startup company called Pristem, which has been able to raise 14 million from Swiss and African investors. And we're very proud about both of them, actually. We're proud because when African investors, what they tell us by investing is, yes, we believe that this could be a solution for our continent. And what the Swiss investors did is they thought, it's robust, it's low cost, has high quality. Why wouldn't it be interesting for industrialized countries as well? So the Pristem is currently industrializing this solution. We hope it'll hit the market in the coming year and a half. Let me tell you about a second example, which comes from our Humanitarian Tech Hub, which is a collaboration between EPFL and the International Committee of the Red Cross. It concerns food prostheses. We've heard about food prostheses before. The ICRC deploys 35,000 of those prostheses every year, mainly for victims of conflicts. Their current existing solution is actually based on polypropylene. It is robust and durable and costs about 50 Swiss francs. The problem is, it is too rigid to live a truly active life, such as the one these people could live if they had access to the more advanced carbon fiber-based prostheses, which are available in industrialized countries. The problems with those ones is that they're very expensive, about 3,000 Swiss francs, and way too fragile. So you can imagine what the ICRC challenged us with. We want all the pluses for 80 Swiss francs. And we did the same. We assembled a team, a larger alliance, where we had 4 of EPFL labs and the ICRC orthopedic team. And we've been able to completely redesign a dynamic foot prosthesis, a robust one, which costs 40 times less than existing solutions, which is also based on carbon fibers. And we've been able to meet that 80 Swiss francs target. And the patent has been filed. So currently, the ICRC is finalizing the tests of this technology in the perspective of its deployment in the coming months or so. But that's not it. Discussions are currently ongoing to see how we can reach beyond the ICRC's beneficiaries, because we estimate that the global need for these prostheses is about 220,000 per year, and mainly for victims of road accidents and people who get amputated as a consequence of diabetes, which, as you know, is a global problem. Now, as a conclusion, let me come back to our foundational question. How can we generate a sustainable impact at large scale? Well, we have to be humble. We have not generated a sustainable impact at large scale with our projects. Because this takes a lot of time. It takes a long time to get there. And it means that we have to be persistent. That we have learned. Oops. The thing we are convinced about, however, is that the answer to that question will necessarily involve 3 ingredients, which are our 3 pillars. We need to cooperate with local stakeholders in order to co-develop solutions together. Interdisciplinarity is essential in order to address the multiple facets of these complicated problems. And finally, there is no way we can succeed without a sound entrepreneurial approach involving the complete value chain. Furthermore, coming back to our 4 horsemen, we also learned that innovations needed to be low cost and economically viable. They need to be simple to use, maintain, and repair. They should mainly rely on renewable solutions, such as solar, and generate no pollution, because there is no way to take care of that pollution anyway locally. And finally, they should be robust and durable. I'm asking you, when I say low cost, economically viable, simple, non-polluting, and durable, isn't that interesting for all of us? I think we need a change of mindset. We need to change the mindset in a sense which could be captured by this revised slogan. Let's design it for the rest, and it'll be fine for the West. I'm convinced that by addressing the needs of the poorest and the most vulnerable on this planet, we all make progress. Thank you for your attention.